All right. Hi, everybody, and welcome to week 3, part 2. I'm going to do the topics review. Again, I would like to say, please make sure you check your emails. Please make sure that you understand I'm going through the review. The review does not count. Make sure you read everything. Right above the review, there's a thing that says information about the review. If you don't read that, then you don't know that this doesn't count for your grade. The only thing that counts for your grade are the learning topics. So please, please make sure you do the learning topics. Okay, so now we're going to start. Okay. This section now is going to be on domains and ranges. So let me see how I can get all this on here at once. Hold on. I'm not sure. I can cut this out, but I'm just trying to figure out if this works, or should I put them side by side like I usually do? What do you think? Because I don't seem to be able to get necessarily the whole.
Yeah, I like when you put it side by side.
Side by side? Okay, side by side.
I understand better.
Okay, side by side it is. Done. Okay, let's do this. Let me make this smaller. And I think we're good. And I just don't want to stop the video right now. Probably should, but I'm not going to. Okay, here we go. All right. I think this is good, right?
Yes.
Okay. Okay, here we go. So this is a graph of a relation. In the last lecture about the difference between relations and functions, this is just a relation. And it says, give the domain and range of H. So this basically is just 3 points. So if I want to know what the domain is, the domain are my X values. So my domain here, since there's just 3 points, I would say it's a set because it says using set notation. This is a set. And actually, maybe the easiest way to do it is let's write the points down. So we have -3, comma, -2. We have 1, comma, 0. And we have 4, comma, -3. There's our 3 points. So the domain being X, and I have to do this in ascending order. So my X values are -3, 1,
and 4.
and 4. Exactly. So, and those are already in ascending order. So I'd write -3, 1, 4. The range are the Y values. And again, this is a set, and it's -2, 0, -3. So in ascending order, it would be -3, -2, 0. Exactly. So that really is the answer to this question. So we see the difference, hopefully, between the last problem, which just had 3 dots. This is called a continuous function. So if I want to know what the domain is, I'm going to put it in interval notation because I can't really name every point, but I can tell you the beginning, I can tell you the end, and then I'm going to include everything in between, which is why I need interval notation. We can see that the graph starts here in the X direction and ends here, right? So good. So my interval is going to be from -2 to 2. We always start from the smallest to the biggest. It's like I said before, we go from left to right, always. So now I look at my endpoints. My endpoints are both closed circles, which means I use square brackets. If one of them was open or both of them were open or any other combination, open circles get parentheses, closed circles get square brackets. So the range, what we're talking about when we talk about the range, is not my X values, it's my Y values. So again, we're going from smallest to biggest. I'm going to go up. That's how I'm going to read this graph. So I say, oh, well, it starts here and it goes to here and it's over. That's it. That's the only Y values that I have. So my range is going to be from, and again, closed, square brackets, -3 to +3. Okay. So far, so good?
Yes.
All right. My domain was -2 to +2. Okay. -2, comma 2 and -3, comma 3. Okay, perfect. Okay, I'm going to do this one as well because this is a little more confusing. I do understand. All right, so we're doing the same thing, only we're going to have to really be careful. When I read this from left to right, this is my first point. So I look at my domain and I come in here and I start here. So I start at -5 and I go all the way to -3, but I don't include -3. And then I stop and I wander, and I start again here at 1, but I don't include 1. I go to 3, I don't include 3. And what I do is I put a union between them. That's basically like the same as saying plus. I have one interval plus another interval. The union is like a plus for intervals. Okay. Now let's do the same thing for Y. Again, for Y, I go from the bottom to the top. I always start with my smallest value and go to my biggest value. So in the Y direction, this is the beginning point. And notice that this goes up to 2. I'm going to put a dotted line because it's not really the end. It can, like, if I'm looking for all the Y values, I still have more Y values up here. The ending of all my Y values is up at the top here. This is more of the confusing part. Okay, good. So really what I'm doing is I'm going from close bracket -2. I actually do have a point here at 2. It's just not here, it's here. So it's continuous all the way till I get till 5. And then we don't include 5. So this is a little more complex. I do understand. So this is still, we're still talking about domain and range. What are we trying to find here? It says find all excluded values for this expression 9/2 plus 6z. If there's more than one value, separate them with commas. Okay. Well, why do I have to exclude any values? Does anybody know? Nope. Okay. Well, the one thing I do know is I'm not allowed to divide by 0. Is that true?
Yeah.
Okay. Since I can't divide by 0, then I have to say, well, what happens? What number makes this 0? Because we cannot have it equal 0. And I just solve this just like any other equation. So I subtract 2 from both sides. I get 6z cannot equal -2. I divide both sides by 6. And I say z cannot equal -1/3. And I think I can do this pretty quick. This side.
What did you say about the 9? I don't know if I missed that part.
The 9 has nothing to do with anything,
Okay.
because there's no problem with putting values in the top of the equation in the numerator. Not an issue. Okay. The only issue is the denominator. I don't know if you remember, I kind of did actually it was an old student who showed me this. So I can divide any number I can divide 0 by any number, but I can't divide a number by 0. So notice what it says.
Mm-hmm.
Okay, so the denominator cannot be 0. Big old no. Okay.
No.
Is that helpful?
Yes.
Okay, so that's one really important thing. But the numerator can be anything. If the numerator is 0, it doesn't matter. I can divide 0 by anything. What's 0 divided by 100? 0, right? So what we want to do when we are looking for domains is we're looking first for what values are excluded. Okay, so to find domains, look for what values of x cannot be included in your answer. So one thing we know is 0 in the denominator, right? 0 in denominator has to be excluded. Well, for this function, I have to really say x minus 5 has to be greater than or equal to 0, doesn't it?
Okay.
I mean, you really don't have to worry. I mean, I just want to explain why I'm doing what I'm doing, but
Mm-hmm.
what you have to really worry about is what's underneath the radical. As long as it's 0, the square root of 0 is 0, because 0 times 0 is 0. So I can make it be 0, and I can make it be any positive number. So now I just solve. So if I add 5 to both sides, I get x is greater than or equal to 5. So this says find the domain of the function, write your answer using interval notation. This is my answer. The first thing I have to think is, what would make x a problem? That's the first thing I always think about. What kind of problems am I going to create with x? I know x minus 5 has got to be greater than or equal to 0, which means x has got to be greater than or equal to 5. If I put that on a number line, then I know it's going to go from here on to infinity. Now that means that my interval for x, well, I can include 5, and I just keep going to infinity. And this would be the answer. Okay?
Okay. So basically, G and the X doesn't mean anything in this equation.
We don't care. We're basically trying to find the domain. The domain is the values that X can take on,
Okay.
right? Can take. Like, let's say I have a car. If I pick up the hood, I have lots of different places to put liquid. So let's say my input for my car is all kinds of liquids. So what's included in liquids? Well, I know I need gas. I need oil. There's parts of my car that need water. Different kinds of fluids, brake fluid, transmission fluid, all that stuff, right?
Yes.
But if I say, what is the domain of my fluids? And I say, well, my inputs are liquid. Can I put Coke in here? Is there any place I can put Coke in here?
No.
No, because what would happen? Blow up the car somehow,
It
right?
wouldn't- Yeah, it wouldn't work.
It would not only not work, it would probably blow it up, right?
Hmm.
So Coke is not in the domain of a car because I can't input Coke anywhere. I can't input lemonade, right? There's many liquids that I cannot put in my car. But there are liquids that I can put in my car. The domain is the liquids that I can put in my car. These are things that I have to exclude, liquids that I have to exclude. Did that make it more clear or less clear?
Yeah, you did. You cleared it up.
Okay, good. Okay, good. So whenever we're looking for the domain, we first want to think, well, what's the problem? Can I put anything in, or is there a problem? If there's a problem, we exclude them. So that's why we think almost the opposite. The domain is only what we can include. So maybe this would be the domain of my car. Find the domain. So let's try this one together. What do I do here?
You solve for X.
I
Well,
have
the
to,
first thing, the domain we're looking for is for 5 plus 4x plus 3.
well, not exactly.
Okay.
I'm only thinking about the problems I could have. So what would be a problem? The only problem is going to occur right here somehow, because whatever, if I can get something out of the square root, I can always add 3 to it. That's not an issue, right?
Okay.
But what I have to do is make sure that what's under the square root has to be greater than or equal to 0. If it's negative, I can't take the square root of it. My function blows up, just like my car, if I put things in the wrong place. Is that helpful?
Yes.
So I don't care about 5 by itself, and I don't care about X by itself, and I don't care about 4 by itself, and I don't care about 4X. What I care about is the combination of everything under the radical. So I subtract 5 from both sides, and I get 4X is greater than or equal to negative 5, and I divide both sides by 4, and I get X has to be greater than or equal to negative 5/4, right?
Mhm.
That's my domain. Because once I can take the square root of a value, I'm in good shape because I can always add 3 to that. So
Okay.
my domain would be, let's look. Try to always put these, whenever you're looking for intervals, until you get to be an expert, please don't try to do all this in your head. Okay? So what I would say is, okay, here's my X is greater than or equal to negative 5/4. I say, well, there's negative 5/4, and I go this way. And I'm including it because of greater than or equal. So that means I would be at negative 5/4, comma, infinity. Is that clear?
Yes.
Very good. Okay, so fill in the table below using the function rule. This is pretty simple. I'm pretty sure this should not be a problem. I have y equals minus 9x minus 1. I'm not going to go through all of them, but when x equals -8, I get y equals -9 times -8 minus 1, which equals 72 minus 1, which equals 71. So I would put that right here, right in there. So 71. 71. Okay. And then I would put in -3. Then I would put in -2. Then I put in 3, put in 7, and just evaluate it.
Okay.
I don't think there's anything really here to talk about. I think that's pretty clear.